All right, we're back. We're on page 5 of notes 2 of Calc AB. We are using the chain rule to find derivatives, and hopefully you're starting to get the hang of this, because the chain rule is really something that, you just use it all the time. It's not like, it's not going to be pointed out to you. It's going to be, do this problem, and in the context of doing the problem, you'll have to use the chain rule, and you'll just have to realize that. So let's keep going. We want to find the first derivative of these things. This problem, we've done like similar problems so many times at this point. So let's see if we can do it. So I'm going to use product rule, and in the process of using the product rule, we're using the chain rule to find the derivative of the first and the derivative of the second. So let's see if we can do it. So dy dx is first derivative of the second. All right, we're going to get a 3 because of the power rule and another 3 because of the chain rule. So I'm going to write 9 3x minus 2 squared plus second, which is this, derivative of the first. We get a 2 from the power rule and a 7 from the chain rule, so I'm going to write 14 quantity 7x plus 1 to the first. I'm not going to write to the first, but it's there. So now dy dx is, all right, what can we take out? So we've got a 7x plus 1 to the first, right? So you're always taking out the lowest power of the factor because that'll be in both products that we're dealing with. So 7x plus 1 to the first, take out a 3x minus 2 to the second. All right, so we're left with in the first thing, we're left with a 9 and a 7x plus 1. So that's going to be 63x plus 9. In the second one, we are left with a 14 and a 3x minus 2. So that's great. 14 times 3 is 42x, and then minus 28. Okay, and then we want to clean this up. So part of why you want to clean this up is if you have to find the critical points, there's always that one extra hidden critical point in these things, and you got to find it. So it's going to be 7x plus 1, 3x minus 2 squared, and then 107x, and then minus 19, I guess. That's a weird one. So the critical points, if we had to find them, x equals negative 1/7, x equals positive 2/3, x equals positive 19 over 107. I don't know, just is. All right, e to the something. So let's think this through. The derivative of e to the something, or e to the blah, or whatever you want to call it, is going to be e to the blah times the derivative of blah, right? So what is blah? Blah is something squared. It's tangent squared, but it's something squared. The derivative of something squared is 2 times that thing times the derivative of that thing. That thing is tangent of something. The derivative of tangent of something is secant squared of that thing times the derivative of that thing. That thing is 3x. Its derivative is 3. And I don't know. I mean, it looks a little better if you clean it up a little bit. So 2 and 3 gives me 6. I guess I don't know, I don't know what the most conventional way of writing this would be. I'm going to go with tangent of 3x. I'm going to go with secant squared of 3x, and then e to the tangent squared of 3x. All right, so there's a lot of functions involved there, so I'm actually going to write them out, right? So, so we had y is equal to e to the u. Then we had u is equal to like w squared. W is equal to tangent of v. And then v is equal to 3x. That's essentially what we're dealing with. There's just so many parts, right? And so if we wanted to find dy dx, we did dy du, du dw, dw dv, and then finally dv dx. So let me go, I'm going to highlight them, I think, in like the original derivative, right? So we have y is equal to e to the u, and then let me try to color code this. This is a lot of colors though, so we'll see. And then I need another color that I really have three colors that I like to have. Like that's really similar to the other one. I don't know if that's useful. All right, so we had dy du, right, which was this. Then we had du d whatever, du dw, right? Then we had dw dv to this part, and then we had dv dx, which is this. All right, so that's what we did, and it worked, I guess. Well, I mean, it definitely worked. The color coding is what I mean, I guess, worked. All right, let's try another one. So we're just doing this, right? Just chain rule straight through. So dy dx is going to be the derivative of something to the 11th is 11 times that thing to the 10th times the derivative of that thing. The derivative of 1 minus x squared is just negative 2x. And then maybe you clean that up. I mean, maybe you don't. It depends on what you're doing with it. Like if you're just matching multiple choice answers, you probably could have done it from the previous step. Ew. Squared to the 10th. Is that all of it? Yeah, that's it. So I would leave that like that. And then here. So I don't know, it's like these almost get easier as you go, but well, I mean, the concept gets easier to use as you go no matter what. So something to the 7th gives me 7, that thing, to the 6th times the derivative of that thing, which is just negative 5. So I think you'd probably clean this up. And then if you've been kind of like looking ahead, you know that the next problem is just insane. And it's literally just insane. Like I just wrote it to see if we could do it. I think we can. This is one usually in class. It's like I suggest that people maybe turn their paper sideways to do it, but we don't have that option here, so we're just going to go for it. All right, so got to keep track of everything here. Dy dx is what we're finding. I'm probably going to have to like move this over, but I also need to see the problem. So what are you going to do? All right, the derivative of sine of something is cosine of that thing, and that thing is the cosine of the secant squared of the tangent of 2x. All right, 1, 2, 3, 4 open. So 1, 2, 3, 4 closed. All right, times the derivative of that thing. So that thing, so I'm going to like highlight inside the derivative as I go. So that thing is the cosine of something. So now we're finding the derivative of cosine of something, like there and there. Okay, the derivative of cosine of something is the negative sine of that thing. That thing is the secant squared of the tangent of 2x. And it's 1, 2, 3 open, 1, 2, 3 closed. Okay, times the derivative of that thing. Now, this is where it's a little weird because the thing that we're now going to take the derivative of is actually something squared. So the derivative of something squared is 2 times that thing. So it's going to be times 2 times, what's that thing? That thing is the secant of the tangent of 2x, close, close, times, so this is how you like keep track of it, times the derivative of that thing. So what is that thing? That thing is actually the secant of something. So now we're taking this derivative. So in the original, it looks like they're kind of out of order, but they're not, right? We're just going to keep going. So now we're going to find the derivative of the secant of something. And I'm just going to keep changing markers here. The derivative of secant of something is secant of that thing, tan of that thing. So it just looks really weird. Okay. times the derivative of that thing. So what is that thing? That thing, I don't really know where the best place to highlight this is. That thing is, I guess I'm going to do, like, I mean, it's definitely here. The one that we're finding the derivative of is actually like kind of sitting here by the chain rule, but it's the same. So like, how can I indicate that? And also, what color is that highlighter? All right, I'm going to try this. We're on the same level there, right? So like now we're taking the derivative tangent of something. So the derivative of the tangent of something, I'm out of space, everybody. So we're just gonna go down the line, I guess. I don't really know. So I'm gonna just say like times the derivative tangent is secant squared of that thing times, oh my God, the derivative of that thing. So that thing is, can you even see that? That is a poor choice. Hold on. What's a good choice here? Maybe this? Yeah, that's not bad. Times the derivative of that. The derivative of that is 3. And we're done. And could I have fit it? I don't really think so. So no matter what I do, it was going to kind of look a little weird. No one in their right mind would try to clean that up, so I'm not going to try. But there you go. That's a bunch of problems that we did. And I'm going to be back in the next video to finish up these notes, maybe depending on how long that page is. But anyway, we're done with this page, so hope you found this helpful.